if you're given a CFG and you know for sure that the CFG is regular, you can actually convert it into an unambiguous CFG by creating a DFA as an intermediate step. So let's look at this following context-free grammar and let's quickly just prove that it is indeed ambiguous. So let's try and form the string just A. So let's begin on the left. We have S, and that we know turns to A, B, A. Now we can make the first A here A. We can leave B as B and A as A. Now we know that A turns into an epsilon, so this capital A will leave as epsilon and this will stay as A. And now we'll convert all of these to epsilons. So you can see we've formed A. Another way we could form A is once again start with the first step with A, B, A, then convert the first A to an epsilon, this B and this is A, and then convert this to an epsilon and this can be converted to an A. So you can see here we've got two ways to form the string A, so it is ambiguous. Now, we know that this language generated is regular, so let's actually convert it to a regular expression. So if we look at what this string is, if we look at what this is actually asking us to do, we've got S, which is converted to ABA. And now capital A can only ever become lowercase capital A or an epsilon. So all that's saying is for this portion of our string, it can be made up of 0 A's or however many A's. So the way we would write that as a regular expression is A asterisk. And then it's the same deal for the A at the end. So we're surrounded with two A asterisks. And remember, it's because your A can actually become an epsilon, so that's why we put the asterisk, because we don't need an A there. And in the middle, it's the same deal, so B works a similar way. B can either become an epsilon or B, capital B. So in this segment of our string, we can have 0 or infinitely many B's. So we can write this as A asterisk, B, and then A. Okay, so if we want to convert this into an unambiguous context-free grammar, we can actually just construct a DFA from this. So let's make our starting state like this. And now our starting state would be an except state, because you can see that an empty string here would actually work. If you just had an empty string, that would be part of our context-free grammar. So let's leave it as S, and we'll make that an accepting state. And now for your string, if you begin and you add an A, it's just going to keep looping back to here, to the start state. However, if you go to a B, let's add a different state. Like this. And now think about just AB. This would still be a valid string because remember, we don't actually need an A here. So this would also have to be an accepting state, and we can label this as T. And once again, if you add another B, it would just continue to loop onto the same state because we can see that this is still a valid string. However, if you were to add an A, we'll need to convert this into another state. So let's label this state as U. And once more, this would also be an accepting state because if we were to have an A at the end, it matches this part of our regular expressions. This would also be an accepting state. And if we keep adding A's, it would still be valid. So we're going to make A and loop it back into the accepting state. Now, of course, if you were now to add a B, this would be a problem because this would no longer be part of our regular expression. So we need to have a fourth state. It can be kind of a dead state because we know that no matter what, once you're at this fourth character here, even if you add an A or B after, it will not be accepted. So we can label a dead state like that. So now that we've actually built a DFA, we can convert this into a context-free grammar. So the starting state, of course, is an accepting state, so it becomes an epsilon. Or if you have an input of A, remember it loops back to S, we get AS. Or if you have an input of B, it goes to T. Now from T is an accepting state, so that's going to be an epsilon. Or if you take the input B, you get back to T. And if you take the input A, you get to U, so you get AU. And then U is going to become, once again, it's an accepting state, so it's going to be epsilon. If you take in the input A, it's going to be AU. And if you take in the input B, it's going to go to our dead state. And we don't really care about our dead state because we know no matter what, we can't come out of it. So we can leave our context-free grammar as this, and this is an example of an unambiguous CFG generated from this CFG.